Hello and welcome to another episode of the Tool Time Podcast. I'm Nadine Mata.
And I'm Eric Garba.
And today we're meeting with Jim O'Hara, the Executive Vice President of Merchandising from CLOR Automotive, to discuss all things batteries. Are you excited, Eric?
I'm excited. This is going to be great.
I think it's going to be a really good conversation. I think we're going to learn a lot. Let's get started.
So. All right. Okay, so let's get started. So Jim, what are the new types of batteries we're seeing in the automotive industry, and are old battery chargers sufficient to charge these new batteries?
Thanks for the question. So the newer types of batteries that we see, some are new-ish and some are really new, but the newer types are really your AGM style batteries, your spiral wound, which is really another version of AGM batteries, and then of course your lithium batteries, all of which really can't be charged with old school batteries, which I refer to as X-curve batteries. So voltage goes up and amps go down. So we can't really charge these newer battery types with those types of chargers because they don't control voltage very carefully or very precisely, which all the newer battery types require. So if we talk about an AGM battery, it's very sensitive to voltage. Yes, it's still a lead acid battery, but it's much more sensitive to voltage than our traditional flooded batteries. Same is true for spiral wound batteries, which are really a subset of AGM batteries. And then, of course, your lithium battery is also very sensitive to voltage. So we need a more modern charger that utilizes a microchip or microcontroller that controls voltage and amperage throughout the multiple phases of the charging process to ensure that we are always giving the battery exactly the type of power that it wants based on the battery type being charged.
Wow, that's super interesting, and it's great to hear that, they're still being updated each year as time goes on and as these batteries change. Can you tell us a little bit about the role of the battery charger and how it's changed for auto technicians in recent years?
Sure, absolutely. So, in the old days, and the old days are only 20, 25 years ago, charging was really a reactive event. So I have a problem battery, I go grab my charger. The battery's run down, grab my charger. Somebody left the lights on, grab the charger. Right. And that's really changed in today's shop. So we like to say hood goes up, charger goes on. So what do we mean by that? So all of our full powered chargers feature a power supply mode on them. So whether you're doing a diagnostic routine or a diagnostic task, repair, a maintenance task, oftentimes those tasks are now going to require stable voltage or stable power on the vehicle in order to perform those other tasks. So this isn't really in the old days, we grabbed the charger, we charged the battery, we were done. So the charger was the task at hand. Now the charger is really being asked to do that, but so much more. So the charger is really an ancillary device that enables other tasks to be performed. So, for instance, if I'm doing an electronic brake job, I really need a power supply on the battery to maintain the system voltage so that the battery doesn't discharge so far that nothing can really be done on it. I can't access the modules, I can't perform my task. So by maintaining the system voltage at a set level, we take the battery out of the equation and we can do the task that we're actually trying to do. And really that's a evolution of the battery charger that's taken place in the last approximately 10 years, where what we were seeing was we would talk to customers back in 2013, 2014, and they would say, well, I'm also using it for this task. So we said, okay, if you're going to use it that way, we really need to change the controls and the interface on our chargers, because a charging routine isn't an appropriate way to handle power supply applications. And the reason for that is as the battery's state of charge changes, what the charger delivers changes along with that. Because remember, when you're charging, the charger's reacting to what's going on with the battery. or at least any good charger would be reacting to what's happening with the battery at any given moment. So it's going to move from phase to phase based on the battery's progression as its state of charge increases. That's the opposite of what we want with power supply. With power supply, we want to just hold the system steady at a specific level, and the charger is essentially providing whatever it takes to hold that. So if there's no demand, the charger's outputting almost nothing. If there's demand, the charger will raise its output to meet that demand to maintain a steady voltage. And again, this steady voltage or constant power is needed in a very wide variety of modern diagnostic, repair, and maintenance applications before we even get into module reprogramming or anything like that.
Right.
Tons of applications on the vehicle today based on the way that the vehicle is configured in the power system of the vehicle. In order to perform those tasks, we really need to maintain a stable voltage on the vehicle.
Absolutely agree. I think first and foremost, making sure that the shops have the best equipment possible in their shops is definitely top priority, or at least should be top priority if it isn't already. Jim, can you share a little bit? Do battery maintainers have the same concerns related to different battery types, or are you able to use them safely for all batteries?
No, they're exactly the same in terms of the concerns. So, in fact, I would argue it could be worse. So, you could put a maintainer on a vehicle for weeks and or months. So, extended exposure to too high a voltage or repeated exposure to too high a voltage is what's really going to hurt these batteries. So, let's use the AGM battery as an example. Voltage in a battery equals pressure. So let's just say an AGM battery, roughly speaking, doesn't want to see anything more than about 14.65, 14.7 volts at 70 degrees Fahrenheit. If I'm charging that battery using an old school charger, or I'm maintaining that battery using an old school charger, the concern would be that you could be seeing voltages as high as 15.2, 15.3 or higher, depending on the charger and the battery state of charge. So over time, what that's going to do is increase the pressure inside the battery, which is going to have a destructive effect on the battery's plates. And eventually will start to break the plates down and start to deteriorate them to the extent that you'll get micro fissures or micro cracks in the plates. And ultimately, we want the plate integrity to be good because that's how we get the recharge. That's what gives the battery its capacity. So as you start to damage or deteriorate the plate, you're reducing that battery's ability to accept energy or hold energy. So we don't want to do that. And especially on a maintainer where you're going to have a prolonged exposure to that charger, it's really critical. If you're using are maintaining an AGM battery, let's say a battery out of your ATV or a battery in that car that you have in the third bay in the garage, or a boat battery that you pulled out of the boat for the winter, you're going to want to make sure that whatever type of battery it is, you have a charger that's optimized for that battery type.
That's awesome. Thank you, Jim.
And now, one more quick note on
sure.
chargers too is I keep referring to microprocessor controlled multi-phase charging, which we would all kind of call smart charging. So there's a lot of the audience out there that says, well, I don't really like those smart chargers. And there's a good reason why. Back in the old days when smart chargers first came out, one of the things the smart charger must be able to do in order to send power to any battery is to recognize that battery's polarity, because the smart charger is going to protect you from a reverse connection. So that's great. But what happens when I connect to a battery that's really low and it can't fire up the circuits inside the charger? Therefore, there's not enough power for me to sense the polarity. So this is the biggest knock on smart chargers in the marketplace today. And we hear it at shows all the time. So all of our product and a lot of quality products out there, but certainly all Prologix products or Clore Automotive products in terms of chargers and maintainers have the ability to override that situation. I call it eliminating the dead battery dilemma, right? So I bought a charger because I'm having problems with my battery, but my charger won't turn on because my battery's really dead. We don't have that problem with Prologix or with any Prologix Charge It, any of our charging and maintaining products. So if the operator has that situation and confirms, and this is really important, confirms that they have a proper connection made to the vehicle or to the battery, they can hold the go or start or charge button down on our product for 3 seconds and force the charger to start charging almost as a manual charger. And once the battery's voltage raises above the threshold required to activate all the safeties will kick in and it'll go back to being a smart charger. So I just wanted to address that because this is a big objection or concern on the part of both shops as well as vehicle owners. When they look at chargers, sometimes they get very spooked by the idea of a smart charger because it's too smart and it's preventing them from doing what they need to do. But we have completely eliminated that on our products and have since day one.
Wow, that is awesome. I really appreciate you sharing that, Jim. That's fantastic because I've heard the same thing many times, and I've even said it myself and questioned, why won't this charger initiate a charge? So that's really great to know.
Absolutely.
Great information.
Absolutely.
Yeah, as a great example, when we first developed our smart charger lines and Charge It and Prologix, I spent a lot of time doing market research on this, and you would go into the forums and somebody would say, let's say you were in an F-150 forum, someone would say, I'm in the market for a new charger. What should I get? And you'd see the savvy guys all say, hey, watch out for those smart chargers for what we just talked about. I bought one, and then I had to use a jump starter to activate my battery to get my smart charger to actually charge the battery. So we built that right into our product, like I say, from day one to address that specific concern, and it's very real.
Absolutely. Yeah, that is fantastic. So if you have, say, an old school battery charger that's still perfectly functional, is that charger obsolete in ways? Or do you feel that there's still a use for it to kind of hang out to it?
Sorry, absolutely. I would say that it is pretty much obsolete, except if you know everything in your fleet is using a flooded acid battery, then you're probably just fine. But if you want all the things that you get from today's smart chargers, like we talked about, power supply mode, reverse polarity protection, all the different things, over voltage protection, etc., you're probably not getting any of that with your old school charger. So it's probably time to upgrade. Like I said, we did a big push in 2013 and 2014 saying it's your batteries have changed, has your battery charger. Now we're 10 years, 12 years past that. It's probably time to put that one away. I'm sure most people got their money's worth out of it.
Oh, yeah, absolutely.
We would hope so.
Definitely agree. So is there, on the subject of jump starters, is there a technology that has changed as well?
Yeah, absolutely. Similarly to the vehicle batteries, where we've seen the lithium come in. And of course, when we talk about lithium in Clore charging, we're really talking about the lithium iron phosphate battery. So all of our chargers are designed to charge lithium iron phosphate, LiFePO4 or LFP batteries. There are a lot of lithium battery chemistries out there used in a lot of different applications. It's really important, just as it's so important that you have an AGM charger for an AGM battery, that you're using the right charger for lithium applications that is paired up with the battery type that you have within the lithium sphere. So there's, as I say, many, many different lithium battery chemistries, and oftentimes they're different cell configurations and different voltages, both nominal voltages as well as fully charged voltages. So Clore's chargers are all designed to charge lithium iron phosphate, LFP, LiFePO4 batteries. So I just say that as a caution out there because all lithium batteries are not equal in terms of how they're charged. So users, professional and consumer alike, need to be careful about that. For our experience, and we're not definitive, but in every application of a starting vehicle application in North America, the lithium battery that we've seen deployed is the lithium iron phosphate battery. So that's why our chargers are designed specifically or optimized specifically to charge that battery type and only that battery type. And then when it comes to jump starters, it's the same thing. So we see a proliferation of battery types in the vehicle car park, and we're seeing that same thing in jump starters. So we have lead acid. Of course, we have AGM lead acid batteries, which we're known for, like the unit right behind me. Then we have lithium powered jump starters, and we have capacitor-based jump starters. So we are fairly agnostic as far as the power supply type or the mode of power based on what is the need of the user or the application at hand. There's certainly a lot of reason to still utilize the lead acid, and there's a lot of reasons why lithium makes a lot of sense today as well.
I love it. All excellent points, Jim. And honestly, it's great to hear that, everything is adjusting as the years go on. And I'm sure a lot of our audience is probably a little scared with change, but sometimes change is good. And that's exactly why we're sitting down and having these discussions so that we can open up, the educational focus and understand why embracing technology is so important, especially nowadays. Switching over to battery testing now, how important is it to use a digital tester, and do load-based testers still have a place in battery diagnostics?
Sure, and I'll just make one more point on the jump starting when it comes to whether you're using a lead acid jump starter, a lithium jump starter, capacitor-based jump starter. Let's say they're all 12-volt jump starters, and you're starting a regular passenger vehicle battery. We don't really care what type of battery is in that car. So it could be a flooded AGM spiral wound or even a lithium iron phosphate starting battery like in your M series BMWs. Because when we connect or it could be the lithium battery in a Tesla Model S or X, when we connect to the battery as a jump starter in a DC to DC connection, what we're really doing there is just augmenting the battery. We're just providing more battery capacity to allow that vehicle to start. And of course, in the case of a traditional jump start, we turn the key or press the button and the ICE engine starts. And all we're doing there is we're just adding additional battery capacity. So we're not charging the battery like we would be with the charger, where we need to make sure we specifically mate the charger and the charger and the battery type, because we're essentially just augmenting the battery, making it bigger, because for some reason that battery is too low of capacity to start the vehicle. Same is true with a Tesla starting situation. So we don't really jump start a Tesla the way we do with an ICE vehicle. But what we can do is there's points right behind the shroud on the front that used to be the grill, but certainly isn't a grill on a Tesla. There's two starting points. We can connect the jump starter. If that low voltage battery is dead, we can connect our jump starter to those starting points and augment that battery and allow the Tesla or EV in other EV applications. We can use the jump starter to allow that high voltage battery to fire up and get that vehicle back on the road. So I did want to make that distinction where with charging, it's really important that we mate the charger and the battery type. With jump starting, it's far more neutral, where all we're doing is basically adding more battery capacity, and we're in the right voltage range, so we're not going to hurt anything. So just wanted to cover that real quickly.
Love it.
And then with regard to testing, yes, so digital testing for sure has a very rightful place in today's shop. And it can do a lot of things for a shop. The biggest thing that the digital tester can provide the shop versus traditional carbon pile, let's say invasive load testing, but specifically carbon pile testing, is A digital tester can accurately test a depleted battery, whereas the carbon pile battery requires the battery to be above 85% stated charge. So if that battery came in pretty low, I have to take the time to charge that battery to at least 85, 90% stated charge or higher in order to get an accurate reading on that battery using my carbon pile. The other thing that I would say the digital testers give you that the carbon pile doesn't give you is the digital testers of today. Well, today's batteries die differently than they did 30 years ago. When I first got my license and learned how to drive, you'd turn the key, and when your battery was starting to get low, you knew it. It took a while for that engine to turn over, and you could kind of hear it, and you'd see it coming. Today's batteries, even flooded batteries, are designed in a way that in many cases, not every case, but in many cases, that battery is ticking along just fine, Monday, Tuesday, Wednesday, Thursday, and then suddenly one day it's just you go from fine to not fine, and that vehicle won't start. And the digital tester is more likely, not perfect at it versus carbon pile, but certainly more likely to identify that ahead of time than the carbon pile tester is. With that said, I spend a ton of time on the forums and interacting with both our channel partners, so distributors, dealers, mobile tool dealers, stores, as well as shops and technicians. And I would say, and of course, I'm on a lot of the forums as well. I would say that most shops look at it very comprehensively, and they're using some mixture of digital testing, like our solar digital testers, like a BA327, and then combining it with something like a carbon pile, so like our 1876. And they're using a combination of those two things. Depending on the situation, it could be a speed factor, it could be vehicle specific, it could be based on their history, knowing certain batteries. But a combination of the two for today's shop is probably the best answer for comprehensive battery assessment. And of course, I will add one more thing. The digital testers, the handheld pocket testers like our BA9, are really useful as triage testers. So one of our experiences is when the tester's needed, everyone in the shop needs a tester at the same time because it's that first cold day of winter. It's a really brutally cold. You went from being in the high 20s, low 30s for highs, and now suddenly you're at 6 or 8 like we experienced last week. And everyone in the shop needs a tester at the same time. And typically the shop isn't going to have multiple high-end printer testers. So what we recommend is taking a small pocket-sized digital tester like our BA9 and having multiples of those for those busy days. So you could test every vehicle that comes into the shop. And if the battery is low, I can test them efficiently, quickly, and accurately with that digital tester versus having to charge it and then put it on the carbon pile. So it's sort of like a mixed bag, in my opinion. If you own a larger shop, some sort of mixture of handheld, smaller digital testers, a tester with a printer for documentation and service, and a carbon pile. That's your ideal setup. Of course, some would say, sure, you make battery testers. Of course, that's the ideal setup. But I'm not the one recommending this. This is what I see on the forums and when I speak to shops and technicians. This is really what I hear from the field.
That's a really great point, Jim, and I agree completely. And as you said, it's what's coming from the field. When we're talking about all the new technology with the testing equipment and the chargers, and how this benefits, the technicians directly, are there any additional types of service that a shop or anything in the shop can benefit from by using this new equipment? That's something that maybe you just don't think about right off the get-go.
Well, for sure, the two application areas that we spend the most time talking to techs and shops about are ADAS recalibration and module reprogramming. So we all the things we talked about earlier about chargers is true. The charger has evolved, batteries have evolved, the usage of the charger and the applications the charger is used to do or being asked to do has greatly changed over the last 15 or 20 years. But the two big application areas that I would say in the last 10 years have exploded are ADAS recalibration and module reprogramming, both of which require a quality power supply to do. Certainly our lower power, so our PL2320, that's 20 amp max delivery, is adequate for a lot of ADAS applications. But like everything else, we have we've been using computers now in the office for a very long time. And our need for memory and power, it continues to grow and it's never going to stop. Well, 4 years ago, 5 years ago, when we had power supply mode on our 20 amp charger, it was essentially enough to handle almost any ADAS recalibration done on a vehicle in North America. And as Eric, as you know, that requirement just keeps growing in terms of the current power demand and the current required. So now we're seeing ADAS calibration situations where it might take 30 amps or 40 amps to keep up with what's going on the vehicle that's putting pressure or trying to drain that battery. So we have to balance that out with greater power. And certainly module reprogramming requires tremendously more power than standard charging or ADAS recalibration. So at the domestics, 50 to 70 amps and Euros, well in excess of 70 amps for sure.
Oh, yeah.
So we have 2 units that are 100 amp power supplies. And those are specifically for module reprogramming, although they're wonderful for ADAS recalibration as well, and all the other tests too. But really, they're purpose-built for module reprogramming because they can deliver 0 to 100 amps on demand. And most importantly, our 100 amp power supplies are super clean. So we have about 60 millivolts of ripple on those, no matter where in the cycle you are. It's certainly no more than 100 milliamps of ripple. So that's exactly what the vehicle wants. When you're reprogramming a module or multiple modules at once, the vehicle wants a super clean, stable electrical system in which to do it. Just like if we're upgrading the software on our laptops, we would largely not do that if we weren't plugged into the wall, because we want to keep that laptop nice and stable, because it should take 15 minutes, 30 minutes, 90 minutes to upgrade all the software that you're doing. Well, it's the same with the vehicle. And it could take 30 minutes. And unfortunately, on some vehicles, it could take multiple hours. So what the vehicle wants is a super stable electrical system in which that upgrade or update or upgrade to take place. So we're providing a super clean, super high power, very responsive to changes in the load demand. That's exactly what that system wants. So we can deliver a very, very stable electrical environment in which to do that reprogram. And we have the ability to adjust the target voltage level for the system anywhere from 13.1 to 14.9 volts in tenth of a volt increments, which again is exactly what the techs and the shops need, because what Volvo wants for a reprogram environment and what Chrysler wants are two very different things. And it's not a one size or two sides fits all, a low and a high or a one. With the smaller chargers, we have the one. It makes sense. It's a 20 amp unit. Well, when we're designing a unit specifically for module reprogramming, just like we want to make sure when we're charging that we have a charger that's optimized for the battery type that we're performing the charge on, we want to make sure our power supply can deliver in an electrical environment optimized specifically to exactly what the OE wants during their reflash.
Absolutely.
So it's really critical, and I think it's really important. And you guys wrote a great article in November in Import Car, actually, on today's need in reprogramming flashing power supplies. So, and what I always say is this: it doesn't matter how you attack reprogramming it. Every shop's answer is going to be different, right? Do I do OE tooling? Do I do aftermarket tooling? Do I use a pass-through device with a PC? All of those answers, it might be yes to all of that, or it might be no, I'm only doing this way. Every shop has to answer that question based on their needs, their customers, the vehicles that they encounter, and the type of work they do. But the one common denominator, no matter how you deliver reprogramming, is the need for a power supply. You have to have it. So, and it's absolutely critical that that power supply can match the OE requirements so that you're delivering the electrical environment that's required by that OE for reflashing, because we know how temperamental that can be. And it's really important to give the vehicle exactly what it needs during that critical function or critical application.
Absolutely, absolutely. This is great stuff. What do you think, Nadine?
Absolutely. I just have to say thank you so much, Jim. This has been very informative, and it's really opened my eyes a lot into how much, the industry really just adapts and changes as everything around us adapts and
Absolutely.
changes. So, it's very promising, and hopefully our shop owners and technicians can learn to adapt and change with us and embrace and accept this technology for sure. Wow, Eric, what'd you think?
That was fantastic. That was great information.
That was a lot of information for sure, but I honestly learned a lot.
So it's just a all around great information, and so much has changed so quickly with
Absolutely.
in this industry, and with batteries. It's easy to forget that things are changing as quickly as they are. It's just something, and time goes by so quick. The next thing you know, all these things have changed, and you're thinking old school. So this has just been great to learn all this great information from Jim.
Absolutely. That's why we're here, right, Eric?
Absolutely.
We're going to discuss all the latest innovations, trends, and technology in the next episode, so be sure to tune in.